Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is median of two sorted arrays. So given two sorted arrays nums1 and nums2 of size m and n respectively, return the median of two sorted arrays. And it's mentioned here itself in the program statement that the time complexity of the algorithm that you will write will be of order log of m plus n. So we will uh, set this as the constraint for the time complexity of our solution, and we will try to write a solution that is of order log m plus n or lesser than that. So uh, basically, the constraints here does not matter much because the accepted time complexity that you are required to submit in itself is given to you. Anyhow, let's have a look at the constraints. So the first length of the first array will be of order 1000, and length of the second array is of order 1000, and m plus n will be of order 2000. Similarly, the elements will lie in this particular range, minus 10 raised to power 6 to 10 raised to power 6. So let's have a look how you will be solving this problem. So we will be, as the problem's time complexity suggests us, we will be using binary search. Now you may ask what we will binary search for. So let's consider these two arrays. Nums1 and nums2. So if you merge these two array, the resultant array will look something like this. And let's say you try to find median in this array. So let's say this is your median. And let's say the overall length will be, let's call this length of nums1 as len1, and for nums2 it will be len2. So the overall length will be this particular array, len1 plus len2. Account for the odd length cases, we will take ceiling value of len1 plus len2 divided by 2, which will be nothing but len1 plus len2 plus 1 divided by 2. This will be your general formula for finding the median of this combined array. Let's call this as our median. Now since these both arrays are sorted, so let's say this particular part, this much part is taken from this array and this much part is taken from this array. Okay, so let's mark the partitions till where the part is taken. So just before the median, what will be the element here? It will be, let's call this left max 1, Let's call this left max 2. So it will be in the case the length is not even, overall length is not even, len 1 plus len 2. It's just a odd length array. Then your median will itself be max of these two values. Left max 1, left max 2. So your median will be this. Now, in case, let's say the length is indeed not odd and it's even, length that I am referring here is of the overall array, len 1 plus len 2. So let's say len 1 plus len 2 is even. Then how you will tackle this particular case? Now your median will be, let me clear some area to write. Yeah, I think here I can write. So let's define another two terms. It will be your right max 1. It will be just a partition, and after this on this this partition will be done on some element. That element will be right max 1, and before this element will be left max 1. It will be actually not max, it will be minimum. Right minimum 1, since we are this part, for this particular part, this is the minimum value. So right minimum 1, and for this it will be right minimum 2. Right minimum 2. So in case your length is even, then your overall median will be max of left max 1 plus left comma left max 2, and minimum of right min 1 and right min 2. I hope till now you are able to understand. We will plus them, add them, and then divide by 2. So it will be your median in case the overall length len 1 plus len 2 is even. In case it's odd, then it will be the answer for your median. So the whole solution of this problem boils down to finding the correct partitions on both of the arrays. So let's consider this particular array itself. The combined array. So let's say this is the median. So the overall median will be len 1 plus len 2 plus 1 divided by 2. And it will be sum of, it will be equal to the sums of, let's call this partition 1 P1. Let's call this partition 2 P1 plus P2 will be equivalent to this median, since some part of P1 will be used, this part of first array will be used and this part of second array will be used, which will extend till here. So adding these two, you will get location of your median. So let's say I somehow find, so what will be the range of P1? If I want to find what will be the range that P1 what will be the range of values P1 can have? So it can have values from 0 to size of nums array, which is len1. So P1 can have values ranging from 0 to len1. So if you know P1, then you can easily find out P2. P2 will be nothing but, let's call this term as median, MED, med. So P2 will be med minus P1. So instead of linearly searching P1 in this range 0 to len1, what we will do is we will use binary search to find the correct value of P1, and accordingly we will find the value of P2. So let me take another slide. We will use binary search, find correct value of P1, and subsequently from P1's value we'll find P2's value. So binary search will be used over this range 0 to len1. Now you may ask, why can't we use binary search for finding value of P2 and then finding value of P1 from the formula? P1 plus P2 will be equal to med. So it's up to you totally, but when, let's say, P1 is having greater length, len of P1 is greater than length of P2, then when you go on finding, let's say you apply binary search on greater length array, P1, and then you go on finding P2, your P2 will be med minus P1. So what will happen is, this particular term will not give you correct index in context of array. Index out of bound will be thrown in Java. Index out of bound. So to tackle this particular problem, we will always use binary search for the smaller size array. That's the main reason why we are using binary search, why we are applying binary search to find the partition for smaller size array only. Because if you apply binary search to find the partition for the larger size array, then your index out of bound exception will occur. You can try it. Then you will be able to understand that, yeah, indeed, that's the reason. So that's pretty much it for the solution part. Now you may ask how you will be reducing your range of your search space in binary search. How we will reduce Search space. Search space is nothing but 0 to len 1. In binary search for P1. So let's take the example that we have earlier taken. So let me redraw it. Now let's mark two partitions. Let this be P1. Let this be P2. Now let's define those four terms that we earlier defined. It will be your left max 1 and this will be your left max 2. Since it will be the maximum value on the right hand side of the partition in this particular array nums 1 and it will be nums 2. And let this be left max right min 2, right min 1, sorry, and it will be right min, since it will be the minimum value on which the partition will be made, right min 2. Now it's very well understood that left max 1 will be lesser than equal to right min 1. The problem arises that the partition not being correct is when this kind of case arises. Let's say your left max 1, this left max 1 is greater than this value, right min 2. Then in that case, your value, your partition that you have made is not correct. Left max 1 is greater than right min 2. The value at left max 1 is greater than right min 2 value. So what you will do is you will try to shift your partition here. So if that is the case, now there may arise another case. It can be a case that your left max 2 value and this particular value. Now let's say left max 2 is greater than right min 1. Then in that case, you will need to shift your partition here. Now you may ask, how shifting this partition will shift this partition? Because these two partitions are related by this formula that we have earlier discussed. Now if you increase the value of this particular partition or decrease the value, it will affect the value of this partition. So I hope you are able to understand. So this will be how you will be reducing your search space in binary search. So let's have a look at the implementation, then you will be able to understand it in a much clearer way. Now let's move towards the implementation. So this we have discussed that we will always apply binary search on the binary search for partition on the smaller array so that the index of the partition for the larger array for the array or say for the other array is well within the bounds of index for a zero indexed array, zero based indexed array. So this particular term should represent a correct partition. So that's why we will apply binary search for the on the less smaller part of the array. In case that's not the case, the first array is of larger size, then you will call the function for smaller array, passing your smaller array as the first argument. So then we will proceed to our solution. Now you will binary search for let me quickly zoom in, or maybe I can somehow, because it's not, it will be not visible in the video, I think. Yeah, I think it's fine. So you will binary search for the value of partition 1 in smaller array, and then accordingly determine the value of partition 2 in bigger array. So this is what you are doing, determining the value of partitions. And once you are done with it, you will define those 4 terms that will help you to reduce your search space in binary search. Now accordingly that you have left or right values left, let's say you decide to make a partition here then it is very much clear that on right hand side you are not having any. Let's say you decide to make a partition here, right hand side you are not having any value. So what you will use for the right hand side? You can use plus infinity, or let's say there is a case that you decide to make partition here. For left hand side you are having nothing, so you can use minus infinity here. Infinity is the maximum value that our integer variable will allow you. So that's for the boundary check of the partition. Let's say your partition was made at a position such that there is no left element available, then you will use minus infinity for that. And let's say your partition was made at such a element that your no right element is available to you, so you will use plus infinity for that, or maximum integer value possible. So that's the case. We can use these values since the values in the array, both of the arrays will lie between this range and will not touch maximum integer value or minimum integer value. So then you will reduce your subspace. If this is the case, then you will move your partition one to left hand side, or to right hand side, sorry. In nums1, and if this is the case, these two cases we have discussed, this case and the earlier case that we discussed, and then you will move your partition in nums1 array towards left hand side. And accordingly your second partition will be shifted because of this particular relation among them. So if both of these cases are not satisfying, then you have made correct partition. Both of your partitions are correct. If both of your partitions are correct, then you will return the median according to the case whether the overall length of combined array, overall length of the merged array is even or odd. In case it's even, then this particular case will be applied. You will pick maximum of these two values and add it to the minimum of these two values and divide by 2. So if it's just a odd length, then you will return maximum of these two values. So yeah, that's pretty much it for the implementation part. Let's try to submit it once. So as you can see, it's getting accepted. The code will be available in C++ and Java both. So thank you for watching. Thanks.